How's it going, everybody? Today we're learning about chemical changes and physical changes. Are you ready? Because that stuff starts right now.
In today's lesson, we're going to look at classifying changes of matter. So we're going to look at how we can change matter in different ways. So there's two ways that we can do that. Can you think of ways that we could change matter? Well, one way is to have something called a physical change happen. So what do you think it means to change something physically? Well, we're going to find out. I hope you made a prediction or a hypothesis about that. The second way is to change things chemically. So we have physical changes and chemical changes. Now, with a physical change, can you think of an example about of something that could be a physical change? Yeah, so we're going to look at an example now in a quick video.
Here's an example of a physical change. What could I do to this paper to cause a physical change? I could rip it in half. It's still paper, but it's two pieces now. It's different, but still the same substance. I could also crumple it up. That's right. Now it's still paper, but it's crumpled up. So that's a physical change.
So with physical changes, what happens? Do we have anything new forming? That's right. So in physical changes, the materials are changing, but there's no new materials formed. Like for an example with paper ripping, well, it's still paper, but it just is in two pieces. Or if you crumple up paper, well, it's in it's in a crumpled up ball, but it's still the same paper. Nothing new has been made. So there's no new properties with that material. The particles are all still in the same place together. They've just either been divided apart or their shape has changed. So things like that are all physical changes. So the physical properties stay the same as before the change happened or the change occurred. So we don't make any new materials at all. Now, can you think of some examples of things that could be physical changes? Well, hopefully you thought of things like this. So if we had, say, a change of state or changes of states of matter, well, if you go from, let's say, a solid piece of ice and it melts to liquid water, well, it's changed state, but have the particles changed at all? No, they haven't. They're still the same particles. It's still water, but as a solid, it's ice. And then as liquid water, well, it's still the same particles. They've just moved farther apart. They're moving a bit faster, but there aren't any new particles being made. Changes of state are a physical change, and you'll see here that there's no new materials being formed, and that the particles stay the same. They just lose their attractive forces when a change of state happens in the example that's given in this video. So let's take a look at that and see what happens.
Matter can transition between the three states when heated or cooled. But why is heat key in all of this? When a material is heated, it absorbs heat energy. This additional energy can cause attractive forces between molecules to break. This leads to rearrangements of the particles because the attractive forces no longer hold them together as tightly. The same happens when a liquid is heated. The attractive forces between the molecules break, leading them to become more widely dispersed and a gas to form.
So you can see here in this freeze frame of the video that the particles of the liquid are the same as the particles that are in the gas. They've just spread out and are moving faster as a gas. Another example would be volume changes. So like we've talked about in previous classes, so the volume could increase if you heat up the matter, but it's still the same particles in that matter. And also the last one is temperature changes. So you can heat something up and it gets hotter, but it still remains the same particles. They haven't rearranged to make any new materials. And also things like the shape of the material, which is the example that was demonstrated with paper that was being ripped into pieces and crumpled up. Okay, next, let's look at chemical changes. Well, in chemical changes, what do you predict is going to happen? Yeah, so with chemical changes, we do have new materials forming. We make new substances that have new properties. So we're making new things with chemical changes. What happens in this case is the chemicals the particles that made up that material or that chemical are rearranging. They're still all the same particles. They've just combined in different ways to make new materials. So an example of that would be like the one that you're going to see a demonstration for in a second.
Now we got the same paper here. What could I do with this paper to cause a chemical change? That's right, I could light it on fire. I could burn it. So I'm going to do that here now, and I've got a lighter and I've got some paper, and I'm going to light this on fire. So let's think about what happens during a chemical change. So as the paper burns, what's coming off of the paper? Hopefully you can see it. There's some smoke. And so that's what's left over after the paper changes chemically into smoke. And there's some ash left of the paper too. But that paper burning is called a chemical change. It makes something new. The new stuff is smoke.
Yeah, so when you burn paper or burn anything, what happens is the particles are going to rearrange. They're going to make new materials. And if you look at the chemical reaction that causes burning, well, you're going to take some things. You're going to take the carbon-based paper and react it with oxygen by adding heat. And when those combine, you're going to get new chemicals. And those are carbon dioxide, actually, and water vapor. Water is a gas. So let's watch an animation of the particles to show what happens during the chemical change called burning. So during this burning or combustion reaction, we're going to start with a carbon-based chemical called methane. That's the one with purple and green. And then the other one is oxygen. That's what you need to chemically react with carbon-based chemical to make burning happen. So we're going to start with CH4 and 2 oxygens, and they're going to chemically react when we heat them up to make fire. So that's what happens. And the bonds or the connections between those particles break apart, and they rearrange themselves. So we get one carbon dioxide particle or molecule, and that's forming there with the oxygen, the carbon, which is the green one represented with the C, and then we also get 2 water particles. So as you can see, the particles are still the same amount of particles. They've just rearranged to make new chemicals, or new materials in this case. So we've got our carbon dioxide, our water particles, and that's what was made from the methane and the oxygen. So new materials with different properties. They're now different substances, but still the same particles are all involved. We haven't added or taken away any of the particles. They all use the same particles, but they just rearrange differently to make new things. Now, when you're in high school, you'll learn more about balancing equations and chemistry and things that actually happen behind the scenes to actually make those chemicals rearrange the particles, or in the case of high school, you'll call them molecules, to make new chemicals. So here's the example, and this is a pretty simplified version. Well, if you burn paper, it makes new things, and those are water vapor as a gas, or is it water as a gas, and carbon dioxide gas. And those are the 2 things that mainly make up, what do you think comes off of the burning paper? Smoke, yeah. So smoke is actually made up of water as a gas and carbon dioxide gas, and a few other things too, but mainly that's what it is. So with chemical changes, new things are made. With physical changes, nothing new is made. That's how you tell them apart. Now let's look at some examples here. So in this picture, you can see that there are a few different examples here. And the first one we're looking at, number 1, is the ice melting from these icicles, turning to liquid water. So I want you to decide, do you think whether that's a chemical change or a physical change. So maybe you can write this down on a piece of paper or just think it in your head, and then we'll reveal it at the end. So what do you think that one is? Chemical change or physical change? That's melting ice. Second example is a person lighting a match. Is that a chemical change or a physical change? The third example is this woman sawing this piece of wood in half. Is that a chemical change or a physical change? Fourth one is the breaking light bulb. Is that a chemical change or a physical change? And then the fifth one is baking bread. Chemical change or physical change? What do you think? So let's take a look at the answers here. So with melting ice, well, are we making anything new? We are making liquid water, but it's still the same particles. So if you guessed physical change, you'd be correct. With lighting the match, where we produce smoke from the match, well, that's a chemical change because we have something new being formed. The smoke is a new material or a new substance. Third one, when we saw the wood in half, are we making anything new? No, we're not. So it's a physical change. With the light bulb breaking, we've got the light bulb, now it's in broken pieces of glass. So again, it's still the same glass, so it's a physical change. Now with the last one, baking bread, we start out with the dough that makes up the bread, and it rises up and cooks to become the bread. Now, technically, I think it's probably a bit of both, because as it rises, it changes its shape, so that would be a physical change. But what I was looking at is the chemical reaction that happens to cause the bread to rise. And that's the yeast, which is a fungus yeah, that's right, there's fungus that you use to make bread. So the yeast is used to chemically react when it eats the sugar that's in the bread, and uses that sugar to make, not really eats it, but uses that sugar to make carbon dioxide bubbles. And those bubbles are the new part that's made after the chemical reaction happens. And that chemical reaction is actually called fermentation, that causes bubbles to form in the bread and makes the bread rise up. So I said chemical change, but really the moving of it rising in some ways is a physical change too. So you're kind of right with both of them, but I was looking for the chemical change part. Anyways, I hope that helped you to understand the difference between physical changes and chemical changes. There's going to be a bit of a worksheet for you to do on a Google form that you can look at, and that's in the assignment that's posted on Google Classroom.
Well, that was chemical changes and physical changes. Talk to you again soon. Bye.